want to take a quick look at an example of a radical equation that's going to require a little bit of factoring. So to recap kind of what we looked at in the last video, we can solve a radical equation. So let's say we have square root of, I don't know, x plus 2 is equal to 10. Well, I can undo that square, or the square root, by squaring both sides. It's going to give me x plus 2 is equal to 100. Subtract 2 and I get x is equal to 98. Plug that back in to check if it worked. 98 plus 2 is 100. Square root of 100 is 10. So that's the valid solution. Now I want to take a look at a different example. I want to say we have the square root of, let's see, what do we got? 7x minus 12 is equal to x. So we can solve this with the same basic method. Is I want to get rid of that square root, so I'm going to go ahead and square that side. And I need to do the same thing to the other side, so I'm going to square that as well. That's going to give me 7x minus 12 is equal to x squared. What's different in this case is now I have a variable squared. Over here, I didn't have a variable squared. Don't have to worry about factoring or anything like that, but here I do. So what I want to do is get this equal to 0 so I can factor and solve. And it's going to be easiest, I think, if you take everything that's on the side where the x squared isn't and move it over. So I want to get everything to the right side. That's where x squared is. Get rid of that 7x, I'm going to have to subtract it from both sides. To get rid of that 12, I'm going to have to add it to both sides. It's going to cancel those. I'm going to get 0 on the left equals x squared minus 7x plus 12 on the right. Now there's a couple ways to factor this, and one of the popular ways that we learned was splitting the middle terms, so I'm going to take a look at that. Consider your outside terms and multiply those together, and I get 12x squared. What I'm trying to do is think of two numbers that multiply to 12x squared and add to what's in the middle, which is negative 7x. Well, let's think. What multiplies to 12? 6 and 2, that'd give me 8. 12 and 1, that'd give me 13. I think 4 and 3 would work, but I want them to be negative 7, so let's make those negative 4 and negative 3. So split up this middle term. X squared minus 4x minus 3x is what we got here, plus 12, that's equal to 0. Take a look at the first two. Take out their greatest common factor as x, and you get x minus 4. Of the last two, let's take out a negative 3 so that we can make that come out as x minus 4. It's equal to 0 still. Bring out our common binomial of x minus 4. What we're left with is x minus 3 is equal to 0. From this, what will make that binomial 0? Well, x would equal 4. From this one, what would make that 0? X would equal 3. So those seem to be two good solutions. Let's go ahead and take those back to the original and see if they work. So if you plug in 4, you get 7 times 4 is 28. Minus 12 is 16. Square root of 16 is 4, so that one works. We're going to take 3 and put that in. 7 times 3 is 21. 21 minus 12 is 9, and the square root of 9 is 3. So both of those solutions are valid.